Hey everyone, ever stop to think about how we can possibly measure something as tiny as a single pill and also something as huge as a fully loaded truck? Well, today we're going to totally demystify mass. We're going to take a journey from the super small to the absolutely gigantic and see how it all connects.
So just take a look at these two images. On one hand, you've got a couple of tiny pills. On the other, a massive lorry. I mean, they couldn't be more different, right?
So what's the connection? Really, think about it. One is something you can just hold between your fingers. The other could practically carry a small house. What in the world could they possibly have in common?
And here it is, the answer is mass. That's the one thing they share. But as you've probably figured out, you can't just use the same approach for both. Measuring the mass of a pill versus a lorry, well, that's going to take two very different sets of tools, and more importantly, two very different units.
So to really get a feel for this, let's go on a little journey of scale. We're going to start at the very bottom of the ladder and work our way all the way to the top.
So let's start at the micro level. For something as small and light as a paracetamol tablet, we use milligrams, or mg for short. It's the perfect unit for things you can barely even feel in the palm of your hand.
Now, let's take one step up. For the kind of everyday things you'd find in your kitchen, like this packet of margarine, milligrams are just way too small to be useful. So we switch to grams, or G. This is the unit you see all the time on food packaging.
Okay, what about something that's got some real heft to it? Something you can still lift, with a bit of a grunt. For something like this bag of cement, we move up again, this time to the kilogram, or kg. And 1 kilogram is just 1,000 grams.
And this is where we hit a bit of a snag. See, that lorry has a mass of about 20,000 kilograms. Saying 20,000 kilograms is a bit of a mouthful, right? And writing it out is just clumsy. It's pretty clear we need an even bigger, better unit for these heavyweights.
So, it's time to meet the solution. This is where the real heavyweight champion of mass measurement steps into the ring, the metric ton.
The metric ton, which we just call T, is a unit we pull out for the really, really big stuff. Lorries, cargo ships. You could even measure whales with it. It's designed specifically for measuring things on a truly massive scale.
Now I want you to burn this number into your brain, 1,000. This is the magic number. Seriously, if you remember just one thing from all this, make it this number. It is the key that unlocks this entire system.
So, the most important thing to know is this. 1 metric ton is exactly 1,000 kilograms. That's it. It's a clean, simple relationship, and that's what makes all the math surprisingly easy.
So how does this magic number actually help us? Well, let's dive into converting between these units. Once you get this part, you'll be speaking the language of mass like a pro.
It all comes down to two simple rules. If you want to go from the big unit, tons, to the smaller unit, kilograms, you just multiply by 1,000. So 8 tons becomes 8,000 kilograms. Easy. And to go the other way, from small, kilograms, back to big, tons, you just do the opposite. You divide by 1,000. So 2,000 kilograms becomes 2 tons. It really is that straightforward.
All right, enough with the theory. Let's put this into action and see how these calculations actually work out in the real world.
So here's our first little challenge. We've got an empty airplane, and its mass is 181 tons and 350 kilograms. Then we add all the passengers and their luggage, which tacks on another 60 tons and 800 kilograms. So what's the grand total at takeoff?
Let's break this down. We add the columns, starting with kilograms. 350 plus 800 gives us 1,150 kilograms. But wait a second, that's more than 1,000. So we take that 1,000 kilograms out, which is 1 ton, and that leaves us with 150 kilograms. Now we carry that 1 ton over to the tons column. So we add them up. 1 plus 181 plus 60 gives us a neat 242 tons. The grand total, 242 tons and 150 kilograms.
Okay, ready for another one? This time, let's try subtraction. Imagine a lorry, and it's completely filled with rice. Its total mass is 10 tons and 250 kilograms.
Now, after all that rice has been unloaded, we measure the empty lorry, and its mass is 3 tons and 750 kilograms.
So the big question is, how much did just the rice weigh? Well, to figure that out, we just need to subtract the empty lorry's mass from the full lorry's mass. And this is such a great example of subtraction in action. You can't take 750 kilograms from 250, right? So here's the clever part. We borrow 1 ton from the 10 tons, which leaves 9. That ton we borrowed gives us another 1,000 kilograms, so now we have 1,250 in the kilograms column.
And now the math is a piece of cake. 1250 minus 750 is 500 kilograms, and 9 tons minus 3 tons is 6 tons. So the rice itself weighed 6 tons and 500 kilograms.
So let's just pull back for a second and look at why this whole system works so beautifully. It really all comes down to a simple, consistent pattern.
The secret sauce is the rule of 1,000. Check it out. 1,000 milligrams in a gram, 1,000 grams in a kilogram, and you guessed it, 1,000 kilograms in a metric ton. It's this simple, repeating pattern that makes the metric system so logical and, honestly, so easy to use for everything from the tiniest pill to the biggest truck.
And to wrap things up, I'm going to leave you with a final thought to chew on. We know a fully grown whale can have a mass of around 19,000 kilograms, and we know a bag of cement is 50 kilograms. So how many of those cement bags would you have to stack up to equal the mass of just one whale? I'll let you do the math on that one.